be curious about.
Maybe you can just be patient on time. Or I'll ask you. How many of you know how to do long division?
No, probably not.
Hands up high. So I want to see. So like possibly a little less than half the class. Okay, that's how many have no idea what I'm talking about?
I know what you're talking about. I know what you're talking about. I don't know how to do it. I'm still like thinking about it.
But you did it? Yeah, when you were young. Okay. So like if I said, what are you talking about? So never mind dividing algebraic expressions. So like if I said this, 571,
Oh.
whatever it was, divide 27.
Okay. Let's long divide it.
So 27. A little double. So it's coming back slowly. No, you don't have to write this down.
Oh, I'm writing it down.
Okay. So anybody remember what we do next? How many times does 27 go into 57? Put that number straight above.
What?
last digit of 57.
What?
Twice.
What?
Because 2 times 7 is 24.
Zero.
Now what?
The one.
Gotta do something else first. I gotta do something else first. I gotta subtract, and then I bring down the 1. Okay?
What?
And then I start the process again. 27 goes into 31. Once. 1 times 27 is 27. Oops.
Minus.
Minus. And I get 4. Which is my remainder. So I get like 21 remainder 4. Or I could write it as a fraction. 21 and 4 27ths. Well, because we're dividing by 27. So 24 27ths go into this with 4 27ths left over. So you may have found that a little challenging. Imagine if I asked you to do this.
I kind of wrote that in this spot.
Well, I told you not to write it. So imagine you got to do the same kind of thinking, except you got to use algebraic expressions.
I made a
So x plus 2, doghouse, 2x to the third plus x squared minus x plus 3.
Only that's a lot. Yeah, why is it curved?
It's not a square root symbol. We're dividing, not square rooting. Yeah. And now you kind of do the same thing, except you go x into 2x cubed. How many times does x go into 2x cubed? No.
Thanks, like. 3.
Yeah, let's just throw random numbers like
I
that.
don't know that once. Good job.
What's 2x to the third divide x?
Are you talking about x or talking about x plus 2?
What is 2x to the third divide x? Listen to what I'm asking you.
8, 2.
You need to stop. Because it's just like, hey, hey, hey. It's like one of the most annoying sounds like you could ever hear. Hey, hey. 2x to the third divide x is 2x squared. That's 8. So 2x squared. Notice I put it above the x squared. So now I got to figure out what to subtract. So I got to go 2x squared times these two. 2x squared times x. 2x squared times x. Come on, you guys. 2x to the third. 2x squared times 2. 4x squared. And now subtract. Notice we'll cancel each other out. What's x squared minus 4x squared? Then minus. Why? Sorry? Sorry? Bring down the next and start all over again. X goes into negative 3x. How many times? Negative 3x squared. Or negative 3x squared divided x.
Negative 3x squared.
Negative 3x. And then you got to multiply by this, and then you got to subtract, and then you got to bring the next one down. Oh boy.
Yeah, old ways, right?
Let's come up with a better way. All I wanted to show you was it can get a little complicated. Okay? Especially when we start throwing variables and exponents in. There is an easier way when we only use the numbers. We don't use the variables or the exponents. And that's something called synthetic division. First of all, synthetic division works whenever we divide a polynomial by something in the form x minus a. So I need to change this to a subtraction. X plus 2 is the same as x minus
2.
So therefore the value of a is negative 2. That's what I'm going to use as outside here. So I'm just working with the numbers. And instead of doing like a big doghouse, I'm just going to do like a half square.
Why?
Now, I'm going to write the coefficients of all the terms from highest exponent to lowest, or to one without an exponent. So what's the coefficient of the highest exponent I'm dividing into? 2. Therefore, the next one would be x squared. 1. The next one would be minus x. Minus 1. The last one would be plus 3. That's how I set up. Okay. Now I need to figure out what I'm going to actually add instead of subtract. So here's what we do. You got to pay close attention to this. Don't miss this. Bring the first one down. And here's the process. Multiply, put it up here, and then add. Negative 2 times 2 is negative 4. 1 plus negative 4 gives me what? Negative 3. Start the process again. Times here, add. So, times negative 2 times negative 3, positive 6, and then add the 2, negative 1 plus 6, 5. Do it again. Negative 2 times negative 2 times 5, add negative 7. These are actually the coefficients of your answer. And your answer would be, notice when we did it long division, notice the first two we got, 2x squared minus 3x, 2x minus 3. See how it matches up? Okay. The question is, what exponents do I write? you start, let me put it over here. Remember, what was the highest exponent we divided into? 3. Therefore, the first exponent in the answer is going to be 1 less. And it's going to go down 1 from there. So 2x squared minus 3x plus 5, because it's just the number, remainder -7. Saves you a lot of time. Because you can see how you get all these x's and exponents in there, it gets very confusing. Okay, so synthetic division is a form of long division that we use when we're doing division in algebra. Okay? For the other way to write it, and you have to know this too, your answer, 2x squared minus 3x plus 5, and then the remainder -7 over what we divided by in the first place, x plus 2. That's what that fancy notation means at the top of the page. Normally we write it like this, we don't write r. Okay? So the remainder always goes over what you divided by. So you need to establish what a is, the number in the binomial that you're dividing by. Set up your synthetic division. Do the process, get your answer. Okay? Again, notice, to figure out the number that we put in here for synthetic division, it always has to be in the form x minus. So if it's +2, it's going to be -2. If it's +5, it's going to be -5. If it's -4, it's going to be 4. If it's -7, it's going to be 7. So let's try this next one just using synthetic division. First of all, what's my value of a? -2. So that's what goes outside my little half square. Here's where you have to be careful. What's the highest exponent we're dividing into? 3. And we have to go in that order. Notice that these are mixed up. So for the x cubed, what's the coefficient? And you got to count everything. For the x squared, what's the coefficient? Is there an x squared? Which means it has no coefficient. And no means 0. Good. Now the x term. And now the constant. Careful. -12. That's how you set it up. Drop, multiply, add. Multiply, add, all the way through. So, drop, multiply, add. Multiply, yeah, 16, add. 25. Multiply, -50, add. -72, 62. Those are the coefficients of your answer. Highest exponent we divided into was x cubed, which means we started x squared. So the 4 is connected with x squared. The -8 is connected with x. The +25 doesn't have an x attached to it. And the last term is going to be the remainder, which we write over what we divided by. Takes a little to get used to. Remember, this is only the second one we did.
Can you like explain like what numbers you're multiplying into what numbers like there? What should
Just a second. What do you mean, what numbers? You got to be more specific. I'm multiplying these two and putting the answer here, and then I'm adding this column. I'm multiplying these two, putting the answer here, and then I'm adding this column. I'm multiplying these two, putting the answer here, then adding this column. I'm doing the same thing, consistent. Yeah. Okay. All right. Now that you know that, or you have an idea, do this one and put your answer in the middle. Actually, you can put it over here because we're not even going to worry about long division. We're not even going to worry about it. Like I said, I wanted to show you how it started, just how crazy it is. So see if you can do this one. One side is looking at. You're able to set up like this. First number always gets dropped, and now it's times. 3 times 2 is 6. Add to get 2. 3 times 2 is 6. Add to get 9. 3 times 9 is 27. Add to get 1. These are the coefficients and the remainder in your answer. How do I know what your exponent to start with? Like 2x, there's always 1 less than what you divided into. So the highest exponents we divided into was 6 to the 3rd. This is going to be 2x squared. Now just keep going down. The next one is 2x. The next one is just 9. And then the remainder over what we divided by. Notice just the remainder over what we divided by, not the whole thing.
Sure. You always try to take one from the exponent, or like does it matter what the like you know how you did 2x and 3?
Yes?
2x2?
And the answer, yes.
Like how like
Because we're dividing by x, right? If we're dividing a highest exponent of 3 by x, that means the highest exponent in our answer has to be 2.
right.
It's like if the highest exponent you were dividing by was x to the 4th, the highest exponent in your answer has to be x to the 3rd. Always. Yes, it would just be x. No, the next one would just be the number. And then the remainder, if there is one. What do you mean if it's higher than 3? Yeah, like if the highest exponent you were dividing was 2x to the 7th, the highest exponent in your answer has to be 1 less, x to the 6th. And then you just go down, x to the 5th, x to the 4th, x to the 3rd. What's that? Not usually, because we can factor those, which we're going to talk about later. That's actually 3.3. Okay. Now, I want to focus on the remainder because we need to know something about the remainder to do the next step in this whole process. Just to sort of keep you guys in focus, these 2 lessons, these are the tools we need to know to graph those polynomial functions we learned about. We need to know some tools in order to do it. And this first one is called the remainder theorem. So look at this. Remember, we divided by x minus 3. So a was 3, right? Do me a favor and find p of 3. That means plug 3 in for x and calculate. So in what we divided by, just plug a 3 in every time you see an x. So 2 times 3 cubed minus 4 times 3 squared plus 3 times 3 minus 6. And then calculate that. So 27 times 2 is 54. 3 squared is 9 times 2 is minus 36. plus 9 minus 6. 54 minus 36 is 18. 18 plus 9 is 27. 27 minus 6, 21. Oh, oh, oh. It's the same as the remainder.
Oh,
That's insane.
why are we being aggressive now?
Okay, that works all the time. Whatever the value of a is, if you plug it in for x to what you're dividing by, you'll always find the remainder. You may say to yourself, who cares? How is this going to affect my life? Well, it may or it may not. Okay, but we do need to know how to work the remainder when we start to factor these big bad boys. Okay, so what if you were asked a question like this? What's the remainder when x to the 10th minus 15x plus 18 is divided by x minus 1? You could do synthetic division. But look at what synthetic division is going to look like. What's your value of a?
1.
1. Highest exponent? And what's the number in front of it?
1.
Okay? Don't copy this down.
Okay, I won't.
Because watch. The next one has to be what's in front of x to the 9th. 0. X to the 8th. X to the 7th. X to the 6th. X to the 5th. X to the 4th. X to the 3rd. X squared. X. And constant. So drop, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. That's crazy. Okay. I have no doubt you guys could do it. But mathematicians are lazy. They are looking for easy ways to do things. Come on, finish. Go. So we're going to find P of 1. We're just going to plug 1 in. For every time we see an x. And that answer is going to be our remainder. 1 to the 10th? 1 minus 15 plus 18 is 4. So if I did that whole big long synthetic division, I would have got a 4 for the remainder at the end. But I saved myself a lot of time. Okay. Now, I throw in this next one here because sometimes, like this is sort of something that could be good for the provincial exam. A question like this, where it's just asked in a bit of a different way. So you have to think a little bit, and you are capable of thinking. For what value of k will this have a remainder of 1 when we divide by x plus 2? Think of the remainder theorem. What's the value of a?
-2.
So if I plug in p of -2 and put a -2 every time I see an x, that should work out to the remainder, shouldn't it? Well, we're told the remainder. What is it?
1.
So we're told that this whole thing with k in it is equal to 1. That means I can solve it. It's an equation. So let's simplify. K times -2 to the 3rd is the same as what? How would we write that? Simplify. -8k.
Oh.
Plus. Next.
-4.
-4. minus 7 equals 1. Notice I've got an equation that I can solve for k. Oh, plus 4 minus 4 is allowed.
Plus 7.
Add 7 to both sides, and I get negative 8k is equal to 8. Therefore, k is, careful, negative 1. Okay? So when you're given the remainder and asked to find one of the coefficients, you set up an equation. But we're going to be using the remainder to factor things, because if something goes evenly into something else, what's its remainder? If something divides evenly into something else, what's its remainder? 0. It goes in evenly. There's nothing left over. No. Okay.